We're on.
So I'm interviewing Dr. Tom, right?
Yeah.
Tom Masick, for my 20% day project at Verocco School. So should we start?
Hello, viewers. Yes, let's start.
So what do you currently focus on in your work?
My work is in new drug development. I study new medications, particularly in schizophrenia, and hope that we show they are safe and effective so that they may be sold to the general public.
Continue. Were you gonna say something else?
Nope, that's what I do.
I don't, does this, also?
Uh-huh.
Okay, and what have you done at CNS in the past?
I have worked in a number of CNS areas in psychiatry and neurology. I've worked mostly in schizophrenia and bipolar disorders. I've done work in ADHD, in cognitive disorders, Alzheimer's and some others. Those are my probably biggest projects. Depression, I've worked a lot in depression and anxiety. So a number of very similar, so did you ask in CNS in general? So I've done, that's in the company, that's a clinical development perspective, so trying to see if new drugs might work. When I was younger, I worked in a lab and I did work with rats on a part of the brain called the hippocampus. And that's involved in learning and memory.
Awesome. So, neurotransmitters.
Neurotransmitters.
They control like a lot in our
Mhm.
brain. But are there like more? Do you think there are more dominant ones or more important ones?
There are two dominant neurotransmitters, at least in terms of what we call fast neurotransmission. The two dominant ones, one is an excitatory neurotransmitter called glutamate, and one is an inhibitory neurotransmitter that's called GABA. And between those two, they send fast signals between neurons. The two primary fast neurotransmitters. There are a number of other neurotransmitters that modulate those effects, and there are some others that do mediate fast, but those are probably the two most important ones from millisecond to millisecond neurotransmitters. I hope my answers are the same as Dr. Nomakosa's too.
The same and complementary.
Yeah.
Okay.
So you had mentioned that you had worked with depression, and with with 350 million people worldwide have been diagnosed with some type of clinical depression. So it's obviously become a major issue.
Mhm.
Do you know like what happens to the brain during depression and how do medications alter that?
Yes, so you're right, it's a very big problem, and it's one of the most debilitating diseases worldwide. The costs of treating depression, not only the medications, but also the loss of productivity, like not showing up for your job or having to get a contractor come in to work for you while they're on medical leave, are huge. Now, there are a couple of neurotransmitters that are involved, that we think are involved in depression, or what's abnormal in depression, and those are the serotonin, norepinephrine, and dopamine. Those are the three big ones. We also know that glutamate is important in depression. They act differently and in somewhat different parts of the brain, but the one we probably know the most about is serotonin. And there's an area of the brain called the Raphe nucleus that projects your serotonergic neurons to other parts of the brain. We don't know exactly what that has in terms of its effects on mood, but we know that in people who are depressed, if you increase the amount of serotonin, through something usually like a serotonin reuptake inhibitor or norepinephrine or combined norepinephrine serotonin, it makes people's depression better. So between serotonin, norepinephrine, dopamine, and now glutamate, those are the most important. Interestingly, now one of the biggest advances in the treatment of depression has been in the glutamate field very recently. And what they have found is a very old drug called ketamine, which is a dissociative anesthetic, it's called. So it makes it, they use it for surgery or for burns. It makes you feel like you're out of your body so you don't sense things. If you give people ketamine, a single dose, it greatly improves depression. And that's one of the most, and that acts through glutamate receptors called AMPA and NMDA. And that's been one of the biggest advances, and we're very hopeful that that will be lead to new medications as well.
Cool. So there, so the are they? So there's there are like a couple major forms of depression, SAD, bipolar.
No,
What?
not schizophrenia.
Oh. So, especially with SAD, how do they seasonal affective disorder? How do they differ from major depressions or major depressive disorder (MDD)? Are the is it like always the same neurotransmitters, and can we apply the same treatments from somebody who has MDD to somebody who has SAD?
Yeah, we think they might be different. It's hard to distinguish because there's not a blood test for depression. There's not, something that it's all based on the clinical interview, that it's sometimes hard to differentiate types of depression. In seasonal affective disorder, the difference is that it's seasonal, that it strikes during the different parts of the year, and it's likely related to the shorter daylight. And we think that another neurotransmitter called melatonin, which regulates your internal clock, may be disrupted. Your normal circadian rhythms that tells you what time of the day it is to sleep and what time it is to wake up, somehow in seasonal affective get a little messed up. That also probably has effects on those serotonin neurotransmitters. So yes, you're probably right. There are other types of depression too that are melancholic depression is one, and you mentioned bipolar depression. We have a theory, and I have a theory that seasonal affective disorder and bipolar depression might both be helped by melatonin. We've done studies with a drug called Ramelteon in bipolar depression because we think there is this what we call a circadian dysrhythm. Your body can't tell what time it is almost. It's it's just off, you know. And we've done some trials that have explored that, and there have been some trials with melatonin and seasonal affective disorder showing benefit, but they're definitely different. They strike differently in the world too, because in northern countries there's less in the winter, less sunlight further north than around the tropics. So yeah, different diseases, different neurotransmitters.
There are two theories on emotions because I'm doing my project on emotions.
Mm-hmm.
The James Lange theory and the Cannon-Bard theory. Which one do you believe, if you use them, is more helpful in what you do, and does the scientific community recognize as correct?
I don't know either of those because they sound like psychology things. I'm not a psychologist. Somebody else could probably tell me what they are.
Well, the canon
He
bard.
can. I told, well, I had actually edited this and put in, if you remember.
Yeah.
And I'm like, because I don't.
Yeah.
We're old.
Yeah, and I'm also more of a pharmacologist. I'm a neurobiologist and pharmacologist than
So
a
the
psychologist.
this has been a big part. Get to teach somebody something.
Yay!
So the James Lange theory of emotion,
Lang.
it says that emotions happen from the interpretation of the arousal. So like event, arousal, interpretation of that arousal, and then emotion.
Mm-hmm.
But the canon bard theory says that the arousal and emotion happen at the same time. So there's no interpretation. They are simultaneous of each other.
So now I don't know a lot about these. The first one is probably where I would guess, because it's not only this is my not being an expert in this field and going out on a limb. I think it's sometimes our misperceptions, our different perceptions of the arousal that lead to different emotions. But I could be, I don't have a strong one. It sounds interesting. I wish I knew more about it.
So in your experience, do cultural influences greatly affect the response to a stimuli? So is it specific to certain areas in the world? Like, would a Japanese person respond differently to a bad grade, or getting a bad report back from your boss than an American person would?
Yeah, there are differently cultural things are valued more. Like you've mentioned, a bad grade as the stimulus. So in different cultures, education is valued differently. In Asian cultures, it might be more highly valued than in, I don't know, the U.S. let's say. So there are definitely cultural influences, and you can even take it a different way. We're talking about negative stimuli, but the loud American is a loud American when we go to Europe. But when we're loud Americans in America, we're just Americans. So you know what I'm saying. It's the cultural acceptance of how we interact with each other, and you can think of other examples in Japan. And in Asia, I had to learn a very difficult lesson about how different Japanese culture was than American. So Japanese don't usually, in general, in public, yell out, at each other, where that might be more common in the U.S. There is other big differences that likely impact how they may react to things, and I think it goes back to what they value.
And this is my last couple of questions,
Okay.
my last bunch. There is literature that suggests that certain colors reflect, especially in the working environment, the different emotions. Are you aware of this research, and do you know whether it's like the colors themselves, like association, like green is nature, or is it the wavelengths that cause the emotions?
So color is so I know the research that some of the research you're talking about, and color is wavelengths. Really, it's the reflection of different wavelengths of light.
That's exactly what I told him.
But so is it the wavelengths? Is it? Yeah, it's because we think of, from what you're describing, like blue is a calming color. Pink, hot pink, it can be associated with irritability or something like that. But this research isn't as well grounded, in terms of, at least in where I sit in my, how we react to things. I know I hate hot pink, so I would probably
Should've worn
become
it.
very irritable if I was in a room all day with hot pink.
Yeah, that's interesting because one of the research papers that I have, college, something from college because it said final one,
Mm-hmm.
colors on mood. In hot pink, in at least the in children working environments like schools and stuff actually raises the the awareness and the ability to receive the information. They did this. They also did another study where they put a group of kids in one room and told them to paint pictures, and the room was hot pink.
Mhm.
And they told kids to go, and the other group of kids was in a blue room. They said the same things, but the room was blue, and the pictures in the hot pink room were happier, and they were excited, but the pictures, and they were also more well done.
Mhm.
The pictures in the blue room were sadder. They weren't as detailed. So
More Picasso-ish, perhaps. He went through a blue phase.
Very interesting.
yeah, thank you.
That's it?
Well,
That
yeah.
was easy.
I had,
What do you want to be when you grow up?